Yes. Hello. Strongest base among the following. These are the four compounds given here, and strongest base pyridine, aniline, pyridine, pyrrole, pyridine. Now, since these are nitrogen containing compounds, the base will be because of what? The lone pair of electrons which is available for coordinate covalent bond formation. Lone pair of electrons which is available for coordinate covalent bond formation. Lone pair of electrons is present on nitrogen, and strong base means which of the following will easily make available its lone pair to form a coordinate covalent bond. Okay. Now let us consider one by one. This lone pair, in case of A, the lone pair of electrons is in conjugation with aromatic ring. So this lone pair, isn't it? Lone pair sigma pi sigma pi sigma pi sigma pi sigma lone pair. So this is what we call as conjugation. So if there is a conjugation, then the lone pair can take part in various resonating forms. So because of that, the lone pair, I will not show all the resonating forms. Because of that, one form I can show. Lone pair when it becomes a shared pair, the pi of this pi which was here will get transmitted here in the form of lone pair. Again this lone pair becomes a shared pair, this pi electron pair shared pair becomes a lone pair, and so these various resonating forms are possible. So because of the lone pair which is part of various resonating forms, it will not be easily available. Okay, how much easily, relatively, comparatively, that we are going to consider. So this lone pair is part of resonance, and therefore the lone pair is not easily available for coordinate covalent bond formation. Lewis base, coordinate covalent bond formation, Lewis base. Okay. Now after this we'll consider B. This, there is a lone pair of electrons on nitrogen, and one may say that lone pair sigma pi sigma pi sigma pi. So there is a conjugation, and this lone pair can become a shared pair, and this pi will go to here. This is not possible. This is because let me write the structure again. This nitrogen atom is sp2 hybridized. So sp2 hybridized means sigma bonds. Ideally sp2 is expected to be in a plane making an angle of 120 degrees. So if these two sigma bonds are in a ring, aromatic ring, the lone pair on nitrogen will be outside the ring in such a way that the overlapping of this with carbon to form a pi bond is not possible geometrically. Spatial if we consider space point of view, three-dimensional arrangement point of view, the lone pair, it is not possible that this lone pair becomes a pi and this pi will go to form a lone pair like what we have considered here, because the lone pair is in sp2 hybridized orbital. Since nitrogen has a pi bond here, this nitrogen is sp2 hybridized, this one is sp3, and therefore lone pair will not be, space point of view, in a position to get overlap on this side. Therefore this lone pair is not part of this lone pair of electrons, is not part of resonance. Is not part of resonance. Now we'll consider this pyrrole ring. These 4 carbon atoms are sp2, 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 sp2. This one is sp3. So one sp3 and all remaining are sp2. So it is in the ring, it is in the plane. The 4 carbon atoms and 1 nitrogen, all the 5 atoms are in a plane. And there is a conjugation, isn't it? They are in a plane. There is a conjugation. Because of conjugation, resonance is possible. So one resonating form I can show. This lone pair, either on this side or on that side, lone pair becomes a shared pair. So shared pair becomes a lone pair, and therefore it would become lone pair becomes a shared pair. And the moment lone pair becomes a shared pair, this pi electron pair gets transmitted here, becomes a lone pair. Now again this lone pair will become shared pair here, and this will become a lone pair. So there is a resonance is possible, various resonating forms that I will not show here, every resonating form. So the lone pair is part of the resonance, and this because of the lone pair which is part in the resonance, the structure is a planar structure. There is a conjugation, means the resonance is possible. And in the ring, pi electrons, because although this is a lone pair, in some resonating form, in the other resonating forms, possible resonating forms, the lone pair gets a pi character. And earlier this was pi, it gets a lone pair character. Lone pair again becomes a pi. This pi becomes a lone pair. Therefore, this lone pair is having a pi character, and therefore during the formula, if we wish to use the formula 4n plus 2 pi electrons for aromatic nature, for a compound to be aromatic, it should be planar conjugation because of that resonance, and 4n plus 2 pi electrons means n equal to 1, 2, 3, 4. If we fill n equal to 1, it becomes 6 pi electrons. So it fits into this formula. There are 6 pi electrons. This lone pair has a pi character in some other resonating form. Therefore, in this formula, we have to count that 2 and these 2. Such 6 are having pi character, and it fits into this formula if n is equal to 1. And therefore, this one is aromatic. So lone pair is not only just part of resonance, but the ring is aromatic. So lone pair is aromatic, means it gives more stability in that form, more stable. So the lone pair is not easily available, not only because it is part of resonance, but it is aromatic. This lone pair, relatively as compared to this and this lone pair is easily available, because this lone pair is not in conjugation. This lone pair cannot form a pi bond. This lone pair cannot be a part of resonating form. This lone pair can be a part of resonating form, but as compared to that, this lone pair is a part of not only resonating form, but in addition to that, it is an aromatic compound. What about this? This is alicyclic. All the carbon atoms are sp2, even nitrogen is sp2. No conjugation. No conjugation. So question of aromatic doesn't arise. And therefore, and all these carbon atoms, aliphatic, they will show plus I type effect, and therefore lone pair is available. This lone pair cannot be donated easily to form a coordinate covalent bond with H plus ions because of aromatic nature. So this lone pair among these four, this lone pair will be least easily available. Although the question is which one among the following is strongest base, means which one among the following will give lone pair easily. That is the question, but we will solve as if the order is asked. Least easily available, and this lone pair is most easily available. So this is the answer actually. These two are resonating forms. The lone pair is part of various resonating forms. Therefore, this lone pair is not easily available. But as compared, if you compare these two, this lone pair is part of aromatic structure. Therefore, this will not be easily available as compared to this and even this. But as compared to this, it will be more easily available because the lone pair is not part of aromatic structure. Okay. So, and this lone pair as compared to these two, because this lone pair of electrons is part of resonance and this lone pair is not only part of resonance but aromatic structure. So this lone pair is present in sp2 orbital and resonance is not possible. Therefore, this is available as compared to these two. And since the nitrogen is sp2 electronegative, here the nitrogen is sp3 hybridized, here the nitrogen is sp2 hybridized, and therefore among these two, this will not be easily available. Nitrogen will pull the lone pair towards it. It will not make the lone pair easily available for formation of coordinate covalent bond, and therefore most basic is this. I have written here. Then the second number, third and fourth. So this is how we have to consider MCQs. Whatever general organic chemistry we have studied, that is of use to solve such examples. And if you consider such examples, again general organic chemistry fundamentals become more and more clear. Okay.